Section 6.5 is called Properties of Logarithms, and mainly we are going to focus on the product property, quotient property, and power property. So when we look at the logarithms product property, if you have log base b m times n, when you are multiplying m and n, you can separate them with their own logarithmic function. So when you have log base b of m times m, you can get their own logarithmic function for m, and then you have to separate them with a plus, and then you can just get the own logarithmic function for n, but make sure that these are the same basis. If we explain this with an example, when you have log base 3 of 9x, so 9x is product of 9 times x, you are allowed to separate 9 and x with their own logarithmic function. So this log base 3 of 9 plus log base 3 of x is going to return the exact same result as log base 3 of 9x. This is called the product rule. When we look at quotient rule, very similar, but instead of if the multipliers are getting if the numbers are getting multiplied, we call it product rule. But if the numbers are getting divided, we will call it a quotient rule. And then when you have log base b of m over n, we will get it as log base 6 of m minus log base 6 log base b of n. We will separate them with a minus. If we explain it with an example, this is a logarithmic function with a base of 1/4. The top number is 4, the bottom number is 5. So we can separate this 4 over 5 with a minus, and we can get their own logarithmic function. And the third, very last important rule is called power rule. When you are taking the logarithm of a number like m to the power of p, p is free to travel to the beginning of the logarithmic function. In this case, we have log base 2 of 8 to the power of x, so x is the power. So x can just travel to the front of the whole logarithmic function, and then it will be the same thing as x times log base 2 of 8, which will be easier to evaluate when we have the real problems. So now let's open the homework for 6.5. Now we're going to actually solve these 6 problems that we have in our homework section. So I'm going to open some room here. So the first question I see is use properties of logarithms to find the exact value of this expression and do not use a calculator. So look, the question is log base 6 of 2 plus log base 6 of 3. So I need to find the answer to this question without using a calculator. When I look at this problem, I don't know if 6 to the what power is 2, and I don't know what 6 to the what power is 3. But if I use the product property, which allows me to combine these two under one common logarithmic function, and I just have to multiply 2 by 3, I can find the answer. So I have log base 6, and 2 times 3 is just 6. So the question is now 6 to the what power is 6, and the answer is just 1 because 6 to the first power is 6. So the expected answer will be here just a 1. Now let's move to question 2 next. So the question 2 on the homework is I am going to evaluate log base 4 of 28 minus log base 4 of 7. And I'm going to find the answer to this without using a calculator. 4 to the what power is 28? I don't know. Only a calculator knows this because 28 is not power of 4. Again, 4 to the what power is 7? I do not know this as a human because only calculator can get this decimal power to find the 7. But if I use properties of logarithms, I can write them together. Log base 4 is the common function. Because the connection sign is minus, that means I need to divide the numbers. And 28 will be divided by 7, and this is the answer I'm looking for. So log base 4 and 28 divided by 7 is just 4. So the question is now very simple for me. 4 to the what power will be equal to a 4. Again, the expected answer will be a 1 because 4 to the first power is equal to a 4. And this is how we're going to do question 2. If we now go to question 3 from the homework, I have log base 5, 4 times log base 4, 125. Okay, Now, this is actually a very different case. So question 3 is this time, we're gonna actually rewrite this expression as a single logarithm. So what I have is here, I have log base a of x minus log base a of y plus 6 times log base a of c. The good thing is all of these logarithmic functions, their base is the same, which allows me to use the properties. Now, these two, I can write them together. They both have log base a, and because they are connected with a minus sign, I know that x needs to be divided by y. And then plus, I have the log base a here, and then this power of 6 can move as an exponent, so this will be the same thing as z to the 6th power. So actually, I want to just start over and I want to tell you something. It will be smarter if we actually combine here the positive number. So the first one is log base a of x, and then I'm just going to write the positive 6 log base of c first, and then I'm just going to put the negative 1 to the end, log base a of y. And then before I use the properties, I'm going to do a little change. Because of the power rule, this 6 can go as an exponent here. So I'm going to rewrite this as log base a of z to the 6th power, and then log base a of y. Now, they all have log base a. Positive 1 stays in the numerator, and negative 1 will stay in the denominator. So this will be the expected answer for this question. So for question 3, you're just going to get C. I recommend producing the similar question to this example because this will be on your test. I want to go to the next one. Actually, let's just do one more like this so you guys understand the idea better. So if I repeat one more time how to do this question, I am going to write log base a of p, and then I'm just going to copy the positive one as plus 8 log base a of r, and then I'm going to move the negative one to the end. Q. Now I'm going to rewrite the first one, but on the middle one, 8 will go as a power here, so I'm going to get log base a of r to the 8th power, and then the last one I'm just going to copy. So since they all have the same logarithmic function with the common base, positive ones will go to the numerator and the negative one will go to the denominator. And this is how we're going to do question 3. For question 4 next. We have this question that I want to write it as a single logarithm. It's 4 times log base 7 of u plus 9 times log base 7 of v. Okay, so because we want to write it as a single logarithm, first thing is we're just going to restore the powers which move to the front of each logarithmic function. So this can be rewritten as log base 7 and u to the 4th power plus, and then this can be, I can rewrite this as log base 7 and v to the 9th power. Now, because they both have log base 7, we're going to multiply v to the 4th. So the first one was u to the 4th times v to the 9th, because we can just multiply these two numbers and that answer is going to go to this box here. And then the last question, number 5 here. We want to again write this as a single logarithmic function. This is what I have. First thing I'm going to do is I'm going to restore the power. So 2 is a power. So the first one, I can rewrite it as log base 7. And then we have x plus 9 here. And then the power is 2. Next, I am going to bring the other terms. And then the last one is also a negative term. Okay. Since everybody has log base 7, this is the common function. The positive one is going to go to the numerator, and this is the only positive logarithmic function, and the negative logarithmic functions will be in the denominator. And then this is how we can solve this problem for number 5 as a single logarithm. This concludes 6.5.